Hello, and welcome to our continuing series of lectures on improving our implementation of a Python object. So what we've been doing is we have been building a series of implementations, of approximate implementations of some of the things that we find in Python, like the Python dictionary. And so the last thing we worked on was this Python dictionary class, and in the previous implementation was just a linked list with a key. Now we're going to eventually have to build all kinds of different implementations, and so the part of what we're doing is we're working toward abstraction, where we're separating what the object is that we're interacting with from how we build it underneath. And so we're going to do things like move our methods into the structure instead of just using prefix style naming conventions, and just reduce the need to look inside the class or inside the structure that is holding our class for code that's in our calling code. So we don't want to have to look at the class class values inside the class. So this is just continuing along understanding object-oriented principles. The three principles of object orientations are encapsulation, abstraction, inheritance, and polymorphism. And so for now we're bundling more things together. That's encapsulation. And we're working on abstraction, and that is thinking about separately how we are going to use this object from how we're going to build the object. We're going to reveal less and less of our implementation details to the caller. Okay? And so for a while, we just said, well, we'll just take the class and add like an underscore and name it, etc., etc. And it seems absolutely simple enough, and in some ways you see that C++ does exactly that when it's compiling C++ to C code. But it seems like it's simple enough, and it seems like you would keep it straight, but it turns out to be a bad idea in practice. So Python strings, which I can write Python code and not have to look up documentation, are real objects that follow the principle of encapsulation. Everything that you touch is inside of the object, like uppercase, searching for something. PHP strings are kind of more archaic in that PHP is more of a C-like way of thinking about things, and they're a type, and then there's a bunch of libraries that know how to use this type. And so I'm going to show you some ickiness in PHP, but I do love PHP, so I'm not just criticizing PHP. PHP has a lot going for it, but in the language and the library there are some annoyances. So let's take a look at a little bit of Python and some equivalent PHP. And so you sort of see this notion that naming convention seems tempting, but it's not necessarily a great idea. So in Python we say x equals a string. We call x.find and have as the first parameter the thing we're looking for. And then we have y equals x.replace old new. And so the first parameter is the old string, and the second parameter is the new string. And then we say how long this thing is. And so everything's very consistent. But if we look at PHP, it's almost identical, except it's calling libraries, right? So $x equals a string with old in it. And then we're going to use strpos. That is the position in a string. And the first parameter is what they call the haystack. And then the second parameter is width, which we call the needle. But then we look at the replacement, which is equivalent of x.replace in Python, and it's not strreplace, it's stir_replace. So do we use underscores or do we not use underscores? And then the thing that just drives me crazy is what would you expect the first, second, and third parameter of PHP strreplace? Well, if I was writing it, it would be the source string, the old search string, and the new thing to replace it with. But that's not what it is. The strreplace says old string, new string, and then the string we're doing the searching in. You can go look this up, but PHP talks about how there were generations of things, like strpos, I think, is one of the earlier ones. Strlen basically that's one of the older ones, and so it's consistent with strpos, but not consistent with strreplace. And so the naming conventions is just less than ideal, and you can just see from a programmer understanding, it's just really simple that if we look at the Python, it says y equals x.replace old new, I can remember that calling sequence, and I can never remember the stir underscore replace in PHP. So the thing we're going to do here is we're going to put the methods in the structure, and so that we see some of our C code before and after. And so we create a PyDict, and then you'll notice that just like what PHP did, I called those PyDict underscore put, PyDict underscore len, and PyDict underscore get. I was consistent because I always used underscores, and PyDict is the name of the structure, PyDict underscore del, and so I was pretty consistent with that. But now what we're going to do in the name of encapsulation is we are going to take all those methods, make them be part of the structure. We're going to find that they're just pointers to the methods, but we are going to have global methods. We're just not going to access them through their global names. So we're going to create a new PyDict saying PyDict underscore new, but then we're going to call, to put something in, we're going to call DCT arrow put. And remember, we have to make this first parameter like the self parameter DCT. That's just always going to be that first parameter because we're sort of doing it Python style. And then you kind of know that Z is the key and catchphrase is the value. And so that's the calling sequence. And again, that DCT comma is just because we're not an object-oriented language, and so we put self in there. Again, homage back to exactly the way that Python did it and why they did it the way they did it, because they were creating an object-oriented framework on top of a non-object-oriented environment, just like we are. And then you look at DCT arrow len, and of course putting DCT in as the first parameter is redundant but necessary. And we can do a DCT get, and we, in effect, other than the first parameter, which is DCT, we are putting the key in, and away it goes, and then we could call the del method. But now you'll notice that every single method that is associated with a PyDict is in the PyDict structure. So let's talk about how we're going to do that and why. And so this all kind of falls under leaky abstractions, meaning that when we're in the main calling code and we sneak in and peek at the data attributes inside the class, we call this leaking. And later we'll talk about iterators and why iterators seem inconvenient and clunky, but what their whole job really is to hide implementation details to make a cleaner abstraction. When the calling code depends on the internal implementation names and approaches, that's what it is to be leaky. So we need to define a contract between the class and its calling code from above that we won't change. And we're going to call this contract an interface. Another kind of word for that is abstraction. And so if we look at all the code in our earlier implementation, the whole thing is leaky, right? Especially if you look at that for loop where it says for struct dnode cur equals DCT arrow ahead, cur not equal null, cur equals cur next, print cur key and cur value. And so what happens is that should trigger a little like that says don't look inside these things. And this is what later we'll talk about iterators, how far we go and how we actually, this code that we're looking at right here, I think it's pretty, but it kind of violates the abstraction boundary because we're looking too deeply into the fact that this is even a linked list. We don't know there's a linked list. It may not be a linked list. It may be some other kind of a structure. It may be a tree or whatever. And we will later get to the point where we will make these things different implementations, not just a linked list. And so that's this idea that like you should be like, oh no, there's this little wall, but now I'm looking inside. And then when you're looking inside, that's when you kind of are violating the abstraction boundary, or we call it a leaky abstraction. What this leads to is the notion of not all object attributes are the same. And so when we're going to build an object, we are going to decide what parts of these things are the contract and what parts are leave us alone, we're going to hide this stuff. And so the concepts in object-oriented programming are that things that the calling code is allowed to see, whether they be data or methods, are called public. Things that are like reserved for class use only are private. And then when we start talking about inheritance, which we won't talk about too much, there is this middle class called protected, and that is stuff that classes and derived classes can look at, but not the calling code. So protected is sort of more like private from the point of view of the calling code. So if you look at the abstraction boundary that we have here, we see that the place where the abstraction boundary is sort of failing is that head and tail. We want to make an abstraction boundary and say that, look, that the notion of head and the tail, that's going to be all ours, and that's going to be all inside. And that's inside the abstraction boundary, and you're not supposed to mess with it. So if we look at how we do this in Java, there is a keyword called private. And so Java, we're making a point class, and we're making it two double values that we're saying X and Y are private, which means you can't access it outside of this class. The constructor is public and the dump is public. And so you see that that just means that you can't access X and Y outside of the class, but you can access dump and the constructor. In C++, you see a private and a public. And so private says this double X and Y are things that can only be used inside the class, and public is the constructor can be used outside the class and the dump can be used outside the class. And this is just syntax that they put in. Now, interestingly, access control in Python is a little sort of wonkier because Python doesn't really put things like public and private. So what Python is doing, and you've seen these across all the Python you've done, where you see these double underscores, dunders, as it were, like the constructor, you're not supposed to call the underscore and init underscore. That's just when you create an object, that's what happens. And so the init is an internal method. It's a private method. Underscore X and underscore Y are totally valid variable names, except we're marking to the outside world, hey, you're not supposed to access these. And then def dump, the fact that we didn't put double underscore in front of it means that it's public. And so double underscore is the signal inside of Python to do access control. And we look at some of the stuff that C++ really does. This was borrowed in many ways from how C++ does things internally. So up next, we're going to talk about this map and the abstraction and the kinds of things that we do under the covers of the implementation details of the abstraction.